Let's go to page 100 and let's do number 113. It's giving that f of ax is equal to log x base a, and you're looking for f of x. Okay, so again, just like before. Okay, so whenever you're looking for this, you have to find a way to transfer this into that. So you want to let this equal to a variable. So you're going to let y equal to ax. Okay, and therefore x will equal to y over a. Okay, then you're going to substitute this into here, substitute this into here. Okay. Okay. So when you substitute the x, so substitute this into here, so it becomes f of y equal to log a of, so substitute the x equal to that, right? So be y over a. So f of y, so what happens is you have two variables over here. You want to find a way to make into one variable. So that's what we're doing. So make whatever this into one variable, and then from there you solve for that individual variable and you substitute back in here, back into here. Okay. So again, when you substitute this into here, okay, this, and so a times y over a give you y, and substitute this into here, you get that. Okay. Now you use the quotient rule for the log. So this becomes log y minus log of a base a. Right? So when you have division, it becomes subtraction in the log. And this is equal to 1. So f of y equal to log of y base a minus 1. I'm going to give a little bit space so you know that it's not a log of this whole thing. It's log of y. This is one term. This is a second term. Okay, now remember, y is a dummy variable. Means you can use any letter. Okay, you can use z, you can use x, you can use whatever. So since we're looking for f of x, then we're going to change y into x. Okay, so whenever you see y, you change into x. So they y becomes x. Okay, and that's it. Okay, let's go to the next one. Okay, you find all the solutions to the functional equation. You have 21 f of x minus 7 f of 1 over x equal to 12x. Okay, so this one is kind of a bit tricky. Notice you got x and you got 1 over x, right? Okay, so the trick is you want to use transforming function. So you want to find a new function by changing the x into 1 over x. Okay, so whenever you see x, it becomes 1 over x. So this becomes 21 f of 1 over x, okay, minus 7 f of, now again, whenever you see x, you have to flip it over. So it'd be 1 over x, right? So again, remember, whenever you see x, you're going to make it into 1 over x. Okay, because again, function is whatever you see, okay, you're going to just replace the letter. Okay, now we're going to simplify this a little bit. Okay, so you got 21 f of 1 over x minus 7, 1 over x equal to x. Okay, and this becomes 12 over x. Okay, now if you notice that you have f of x, notice this over here. Okay, so we're going to use elimination method between these two equations. Okay, so I'm going to multiply this by 3. So I get 63 f of 1 over x minus 21 f of x equal to 36 over x. Okay, and now I have the opposite, so I'm going to move this equation down here. Okay, move the first equation down here, and I'm going to rearrange the terms. Okay, so I get minus 7 f of 1 over x plus 21 f of x. Okay. And now let's not multiply this by 3. Hold on. Okay, let's start it over. Because right now we end up eliminating the f of x, and we don't want to do that. That's what we're looking. We want to eliminate this one instead. Okay, so let's start it over. Okay, so you got 21 f of x minus 7 f of 1 over x equal to 12x. And going to make x become 1 over x. So you got 21 f of 1 over x minus 7 f of 1 over x equal to 12 times 1 over x. There we go. Okay, then you're going to simplify a little bit. Okay, so we try to eliminate the inverse x. So we're going to multiply this by 3. Okay, so multiply this by 3. So this equation over here, multiply by 3. And we're going to put over here. So multiply by 3, I get 63 f of x. Okay, multiply this by 3, I get minus 21 f of 1 over x. Okay, and multiply this by 3, I get 36x. There we go. Okay, then when we add this, we cancel out, and this one I will get 56 f of x, and this will equal to 36x plus 12 over x. Okay, so again, so what we did earlier is we did eliminate the wrong part. We end up eliminating this, so that's not good. So we want to eliminate f of 1 over x. Okay, so now we can go and solve for f of x. Okay, so we're going to divide by 56. So f of x will equal to 36x over 56 plus 12 over 56x. And if you simplify a little bit, you're going to get 9x over 14 plus 3 over 14x. Okay. Now, if you want to get a bulk answer, then what you do is you can kind of factor out the 14. So you're going to get 9x plus 3 over x over 14. Okay, let's go to the next one. Okay, so it says if g of x equal to 1 minus x squared, and f of g of x is equal to 1 minus x squared over x squared, and x cannot equal to 0 because it will make this undefined, then you're looking for f of 1/2. Okay. Okay, so first, let's go and get our function. So g of x is, we substitute this into here, right? So this becomes f of 1 minus x squared. Okay, so that's that. Okay, and we're looking for f of 1/2. Okay, so that means we need to figure out what x. So we need to find out what x squared is. Okay, so and again this match, right? So you can go to the side. So 1 minus x squared equal to 1/2. Okay, so so move this over. 1 minus 1/2 equal to x squared. So x squared equal to 1/2. Okay, so f of 1/2 means x squared equal to 1/2. So whenever you see x squared, you substitute into 1/2. So you got 1 minus 1/2 over 1/2. Okay, so again f of 1/2 is when x squared. So again this is this, right? So this is when x squared equal to 1/2. So when x squared equal to 1/2, you get that. Therefore x squared equal to 1/2, you get that. So again, you have to kind of be consistent. So f of 1/2 will equal to 1/2 over 1/2. So f of 1/2 will equal to 1. Okay. Okay, let's go to the next one. Okay, it says if for all x, f of x equal to f of 2a to the x and f of x plus 2 equal to 27 f of x. Okay, you're looking for a. So sometimes this is kind of misleading. Sometimes they give you extra stuff that you don't need, like this one you don't need. Okay, so you're looking for, so in this case what you do is you want to find a. So what you do is, since this is f of 2a, I'm going to use evaluate. So f of 2a. Okay, so notice that so whenever you see x, it becomes 2a. Okay. So whenever you see x, it becomes 2a. Right? Again, x becomes 2a, so x becomes 2a. Then from here, what I'm going to do next is I'm going to divide both sides by f of 2a. So divide both sides by f of 2a. So this becomes 1. Okay, and now you use the quotient rule, right? This is 1 power, so this becomes f of 2a to the 2a minus 1. Okay, and there's no fraction of it. Again, when you divide, you subtract the exponent, right? This means this is 1 power, so 2a, okay, 2a minus 1 give you that, right? Now from these, right, so f of 2a to some power equal to 1, that means exponent has to be equal to 0, right? Because something to the 0 power will give you 1. So from here you can see that 2a minus 1 equal to 0. Okay. And by solving, you get 2a equal to 1, so a equal to 1/2, and that's it. So you don't even need use that.